All right, so we're live. So good morning, welcome everybody. In today's TSC meeting, the primary subject is µONOS, and for those who have not heard, that's the code name for the effort to develop a new architecture for ONOS. We decided to stick with the branding, with ONOS branding. So basically, the idea here is that the current versions of ONOS, which is ONOS 1 and ONOS 2.0, which are fundamentally the same. The only way they differ is in the version of Karaf and Java that they run on. They will continue to be developed. ONOS 2.0 will continue to be developed, and all of the LTS releases will continue to be supported. But in parallel, we will be working on developing new architecture for µONOS, which is basically part of what we envision as part of the next generation SDN software stack. So that's basically it. I think everybody should be familiar with kind of the architectural tenets, so we don't need to go over it. We do have a working document, which let me share on a screen. Just realized I wasn't sharing. Working document on Google Docs. I think the link is publicized in various places, including on the wiki. And this is where we're articulating some of the reasons for why we're doing this, some of the principles that we're adhering to, and then starting to flesh out some of the high-level objectives for this effort. The first kind of thrust of this effort will be to focus on a configuration subsystem, because this is something that is somewhat lacking in the existing architecture of ONOS. And the idea is to develop it under the new architecture, and then for a limited amount of time, like during transition period, we can actually run it side by side with the existing ONOS architecture until the full µONOS architecture and components have been implemented. So to prepare for this, the work will be hosted in separate repositories. The existing ONOS repo, Git repo, will continue to house the work on ONOS 1.0 and ONOS 2.0, whereas the µONOS work will now be hosted in several different repositories that have been created for this purpose, and they have been named ONOS-something. So, for example, ONOS-config, ONOS-control, ONOS-topo, and there may be additional ones. And the idea is to develop the project in a disaggregated fashion out of multiple different repositories, which is in contrast to the existing monorepo that ONOS has. So that's where things are. Some check-ins are already starting to happen into the ONOS config repo, and I can let Sean and others talk more about that later. But that's where we are. The project is basically just starting to take off. A few of us from the core team will be attending a work week in Milan, in Italy, in a couple of weeks. Thanks, Andrea, for hosting that at the local university. And clearly everything is happening otherwise in the open. So we welcome people to participate, comment on the document, provide content. I think like a great example of such behavior is, for example, from Adi. He's a PhD student from Purdue. He's been very actively participating in these discussions, so we welcome others to do the same. So that's kind of just me providing a brief update here as to where we are, what the nomenclature is. And I think at this point in time, I think I can hand it over to Andrea and Sean to talk more about some of the design details for config and some of the initial work done in the repos.
Yeah, thanks, Tom. I took over control of the screen.
Perfect.
Can everybody see it?
Yes.
Okay, perfect. So thanks for the introduction. That was good, very good introduction. So what we're currently at the moment, as Tom was saying, it's work that has been done in the open, and the repo is Open Networking Lab -ONOS config. Again, we will start with the configuration stuff, and there's a README in here which updates, just gives a brief overview of the key tenants and the different stuff that we're going to try and do with this ONOS configuration component. Licensing is Apache 2 license, so it's the same as ONOS before. We decided to go for GitHub because it has a better integration, and we're going to keep the docs within the repo itself, so it's going to be versioned with the repo. For now, there is really nothing committed to the repo yet, except for this testing device simulator, which Sean put together, and he's going to talk more about later. The idea is that for now, there's a few branches. If you take a look at here, there's this first step branch, which in turn has instead some stuff in it, and which Sean did a great job in starting an effort around the core component with does storing and rollback of the configuration. I did an initial implementation and work around the GNMI southbound component to provide a GNMI client and the capability of spawning different clients and connecting to different devices. And that's also why the emulator is there. My work is not yet uploaded, but it's just a small client for GNMI, which stores some data. Having said that, I'll pass it over to Sean to see if he can talk about it a little bit about his work.
Hi, thanks, Andrea. Can everyone hear me okay?
Yes.
Yeah, okay, let me see how I can share the desktop here. Give me 2 seconds. Are you sharing it at the moment?
I made you presenter.
Yeah,
Sean.
okay. Let me see, enter screen. It's not giving me the option to share the entire screen. Let me just go with, I'll just have to go tab by tab, but that's okay. Yeah. It's frustrating. Ubuntu is not great at sharing things with GoToMeeting. You can hopefully see my desktop here. Yeah, okay, so this is just the Chrome side of things. Let me see, like Andrea said, so the simulator really is something that hopefully people can run on their Mac or Linux, and basically just sets up 3 devices. And these devices are configured with certificates and all of this, and then you can use the GNMI CLI tool for connecting to it and passing configuration, retrieving configuration, getting capabilities, and so on like this. So I'd encourage people to have a look at that. That's when we started the development. So Andrea started on the southbound on the GNMI, and I started kind of in the middle with this ONOS config manager, and I looked at the storage. And a sort of important point I have here is here's a slide basically on how I chose to structure the internal storage. So basically what we wanted is we wanted a versioned database of config, and so the idea is that we have a config store and we have a changes store. Yes, Andrea?
Did you change your screen to something else? Because I'm still seeing GitHub.
Okay. Okay. I did, and it didn't update. Let me just change it again. Go to meeting. There we go. Let me see. It's this one. Yeah. Hopefully you can see this. Yeah, so basically the idea is that there's a change store and there's a configuration store. So the changes basically are these immutable changes that are like, you know, a set of configuration attributes that have been changed. And what they do is the configuration basically layers these changes on top of one another. So change 1 might be the base configuration, change 2 might be a change made to it later on, and change 3 is a further change to it made later on, and it's done by overlaying each configuration on top of the other. And that's what I was hoping to demonstrate now. So hopefully this sharing will allow me to do that. Just give me a second. Hopefully it's possible. So I'm going to try share an application window. Give me a second. Yeah, so here's the code in action. So what I have is I have a sample change store. Can you see the IntelliJ?
Yeah.
Yeah. So basically here's an example of a change store. So here's like I think this one is the base configuration. So this is the original configuration, and then here's another example of a change that has been overlaid on top of it, where, you know, the transmit out number 2 is deleted, and leaf 2 C is changed in value from you know, ABC to DEF. So here's 2C and ABC and DEF. And so what I have is I have I'm going to have to share this individually again. Hopefully this is the last change I'll make. Doesn't allow me to doesn't allow me to display my terminal window. It's okay. I'll do it in IntelliJ. So let's see. So terminal. Okay. So I have. It's a little bit unfamiliar, but yeah. So here's the way of doing it. So I can paste this in here, hopefully. And let me see, go run. So basically this runs the configuration manager, and it loads up these 2 data stores that I showed previously. So let me run like this. So what it does is it gives you this small menu. So basically what I did is I just implemented a simple menu. In time, this won't exist. It'll be replaced by a northbound interface through GNMI, where you'll be able to list changes and show the configuration for devices and do all of these nice things, make changes. But really, to get started and to start prototyping the structures and so on like this, I implemented this interface. So let me just show you some of the commands working. So here, for instance, is C. And basically what it's doing is it's showing me the 4 changes that I have. And if I want to see, say 3 in more detail, I can see my configuration changes. So, you know, it's basically, it's just a tool for playing around with configurations. But what it does is, this is my list of changes, but I can show the configuration then for a device. So I'm just going to show device 1. And it's showing that I've got 3 changes in a row, like I showed in the slide. Okay, and then, you know, I can extract those, and this allows me to say I want to see the latest changes consolidated from all of the changes that I have for that device, or I can go back 1, or I can go back 2. Changes and see what the configuration was like back then. So this for instance is the complete configuration, and it's showing that leaf 2C has been changed to DEF here, and that TXOut2 has been removed. Whereas, like, if I was to show this configuration, device 1, and I go back 1 change, then I get my configuration here with ABC for leaf 2C, and now it's showing TX out 2. You know, so there's this is kind of getting at the core of the internal storage structures, and you know, making sure that they can give us the kind of flexibility and functionality that we want from the system. And so, you know, I mean, this is I think a first expedition into programming in Go, and you know, maybe stuff will get restructured. In fact, this week I've done a lot of restructuring, you know, breaking it out into all of these files, and basically, you know, for instance, I have a file now for the individual change class or change struct, the change value struct configuration, and so on like this. And then there's a whole load of tests, unit tests, basically for the Go program as well, that you know, loads in various different configurations and tries out various different things, you know, changing things with a bad path, you know, having a duplicate path, you know, trying to get as much coverage as I can on those internal storage structures. So really, you know, it's a very rudimentary thing at the moment, but basically it's establishing those internal storage structures to give us the kind of functions that we want the end system to have. You know, what we want is, we want to be able to make a change to a device, and only those changes to go down through GNMI, not to ship the whole configuration down again. And that's a crucial point, because you know, devices in the field, you know, don't want to have to receive a full configuration. They want to update their configuration, and GNMI is built around that. There's a method of, when you send down a configuration with GNMI, you specify what's deleted, what's replaced, and what's updated. You know, and this internal storage structure is leading us in that direction. So for me, with this, I think the next step will be to link this up to the southbound interface that Andrea was talking about, and being able to push those changes. And I think after that, then linking it up to the northbound interface. And what I've done here, you know, by just having storage files here, you know, I didn't want to get into how we're going to store these, how they're going to be stored across the distributed system. I just wanted an abstracted interface for storage, and these files are giving me that for the moment. And I think they will be fleshed out with a distributed storage backend, you know, as time goes on. Okay, that's probably all I had to show on it.
Sean, have you come across any have you come across any other people who have tried this? It looks very similar to the event sourcing pattern you see in some other pieces. Other people have proposed for structuring sequential time data and configuration.
Well, I guess the inspiration for this was Git. Actually, you know, so I mean, a lot of the concepts are very similar to Git in terms of commits, and you know, you could effectively call the sequence of changes here a branch. So I think it probably is a very familiar model, you know. But then again, you know, and a lot of it has parallels in GNMI, and you know, a lot of the sort of structures that Google have put in place. I guess, you know, I think there is what's, you know, particular about this is that, you know, it's configuration. It's kind of following the kind of structures that are in Yang, for instance, lists, leaves, containers, you know, choices, all of those kind of things. And you know, I guess I have a lot of experience in those things, and I you know, I wanted to make sure we had something that follows all of those things. And you know, I had to kind of find some common ground, and I guess it probably does match a lot of design patterns out there, and pretty similar to a lot of them. Do you have a suggestion of a particular one to look at?
Yeah, you might look at the event. It's usually called event sourcing, but it handles a lot of the mapping of sequential change data onto a queue. So once you guys get to the point where you're needing a data store that's distributed, the event sourcing pattern might be one to look into.
Okay.
So
that's a good link and something we'll take a closer look at for sure.
Yeah, we were over in the core team was looking into something like that a while ago, but we didn't go down that path because it might be the right decision, but it is a big redesign. But as ONOS is doing a big redesign, it's probably the right time to look into that.
For sure, and like, you know, there are simplifications going on here. You know, there are things like, you know, these things are stored as string text for the path, and, you know, I mean, maybe there's a better way to do that for simplicity's sake, though, and to tease out the use cases and you know, what people wanted out of these things. There are basically a number of simplifications that we've made for the moment. I think, you know, the important thing here is to get something started, and you know, the code is in public, and people are welcome to have a look at it and play with it and make changes to it. You know, I mean, the API, I guess, is for the moment is, you know, it's got to satisfy these test cases, and that's kind of where we're at the moment. And Andrea, I think you had a big set of slides describing the kind of functional use cases that this thing is expected to satisfy as well.
Yeah, so actually we do have for a configuration system, if you were to go to the, there's a set of design objectives that we're aiming for. It's in a very concise form, and it's basically at least the purpose of the base configuration subsystem is to extend the transactional capability that GNMI currently has for a single device, to extend it to basically multiple targets or multiple separate devices, so that we can essentially apply all of the configurations across all of those targets, or none of the configurations if something happens. That's one. And the second feature is to be able to roll back and roll forward the configuration in time. Now, clearly there is a limitation, and this is where some of the similarities to Git starting to disappear. You know, clearly with Git, we can probably take a change, a particular change made in time, sometimes in the history, and selectively pluck it out of the change tree. Clearly with networking, with multiple applications making changes that are cumulatively dependent on each other, some of that will be limited. And right now we're limiting it basically to be like a change queue, precisely, rather than just to be a change graph. Basically, we should be able to, or it's more like a change stack really, where the latest changes that were previously applied can be undone, but they have to be done strictly in a last in, first out type order. And so some of those design objectives are articulated in the document, including some of the additional features that we'll be layering on top of this. Now, when I said base configuration system, so the base configuration system, we envision to be the GNMI on the south, the GNMI on the north. The GNMI on the north will be basically carrying through exactly the same models that are intended to go to the environment, but will be in scope, will apply to multiple different targets, the configurations. We expect that on top of this base configuration subsystem, we will be able to build additional higher level components, such as, for example, intent-based configuration or additional applications of the same sort. But those will most likely have their own northbound APIs and northbound abstractions. Again,
and that's also what Sean was coming at when he was talking about having a a CLI and a set of things that can interact with the northbound GNMI of this subsystem to create the CLI service, a REST API service, maybe eventually a RESTconf if we even want, a set of applications, a graphical user interface. But having a clear defined API such as GNMI on the northbound of this component can definitely be good to abstract anything out of this with a common set of interfaces and models. We have nudged at it, but the whole structure of this will be based on Yang models. That's the language that we're looking at, even though GNMI supports any tree-based structure, not only Yang models. But we're going to start looking at, for example, OpenConfig Yang models. That is the clear target for our first implementation. And those we are going to use for the device-centric APIs. And we did not mention it, the generation of the proto buffers to enable the workflow will be done through the YGOT toolchain. Again, open source that takes a Yang model and generates proto buffers out of it in order for then to generate automatically bindings for many different languages. In our case, we will be write bindings in Go.
Yep. So I realize we're kind of jumping all over the place here a little bit, but the purpose of this is to provide update and a discussion forum for the progress that's made kind of on the overall µONOS front. So at the same time, while we're trying to kind of set up the project for across the whole front, we're making some advances into the configuration front at the same time. Also in the background, we're articulating further some of the use cases for which we're intending to apply this. Sorry for scrolling quickly here. We've started to articulate some of the use cases where we want to focus on demonstrating the capabilities of µONOS. So one of these is a self-sufficient network, which is basically part of the next generation SDN stack, which includes Stratum, as well as some of the network functions, which may either reside on Stratum switches or be hosted in a centralized location on the control plane. It includes zero provisioning, some specific use cases and use models. We're also articulating some of the environments where we want to apply this, specifically a network access edge. That includes various access technologies like CBA or RAN edge, and clearly involve a fabric for hosting some of the edge functions and managing egress to intranet. So that all of these things started to get articulated, at least at the high levels, just to provide kind of a frame on top of which we can start to revolve our thinking as we make design decisions, right? So that we know kind of what to tailor our design decisions towards. One of the things that I wanted to bring up specifically with the RAN edge, the radio access networks, they have some specific requirements with respect to guaranteed and predictable latencies. So it's being talked about as being near real time. For all practical purposes, I would consider real time. And again, real time doesn't necessarily mean fast, it means predictable. In this particular case, it's fast and predictable. And so some of these interactions that the devices, and ultimately this includes user handsets, along with all of the equipment that's required for them to maintain connectivity, some of those interactions require certain latency guarantees in order for the user experience to remain seamless. And those requirements may translate into a mixture of approaches that we'll have to employ and a mixture of technologies or some limitations that we may need to impose on technology. So, for example, there may be a 10 millisecond or sub 10 millisecond budget that's given to the platform, and the applications can rest on top of it in order to be able to manage a handoff between, as user roams between different edge points. And that may have impact on what kind of languages we use. For example, Java is a garbage collected language, which is subject to potentially unpredictable stop-the-world pauses. That may have an impact on our decision. Go is garbage collected language as well, even though it seems to offer better controls for managing garbage collectors, but it still may, some of the components may not be able to be written in Go, and we may need to rewrite them in C++, for example. Again, we wanted to at least put some of this in writing as to what's expected, and so that we can, when it comes down to deciding on an approach or on a tool set, we can make the appropriate choice.
And I know this is a lot of information, but there are any questions, any thoughts?
One of the, again, just to jump around some more, one of the topics that we talked about as a result of the previous meeting on this project was on decision on not only on the repositories that we would create, but also on specific project structure for the Go projects. Clearly, the ONOS config is going to be done in Go because there we don't necessarily have any of the latency constraints that I just talked about. And so there were suggestions from various members in the community, Adib included. So Adib was kind enough to do some research on best practices of various Go projects, and he filled out his document, this portion of the document on a project structure. So this is what we will be using for our project as well. So you can probably already start to see some of the structure slowly beginning to flesh out in the ONOS config repo. That's what we intend to use. Yeah, I think Nikolai, I just saw your comment. I believe that is precisely what is being followed.
Oh, okay, thanks.
Yeah, and again, as we are trying to learn the rules of the game and also in the Go language, so that is definitely a very good option, and we will probably use that element as a structure for the project as soon as it comes in. But yeah, feel free to chime in with comments, commits, and pull requests and ideas at any given time through either the email lists, the GitHub repo, or really anything. We encourage participation from everybody. I know the code is not that much for now, but I think it proves some initial good value.
So my initial question, I mean, this is my first time here again. It all sounds very, very, very interesting and exciting, actually. But do you plan to move the project to its own GitHub project? Because it's currently under Open Networking Clubs, and I guess it's nice for now. But maybe at some point it needs to go to its own place.
No, that's not something that we really thought about. It's what do you mean? I mean, it's currently, because I'm not quite sure what you mean. So currently under its GitHub Open Networking, Open Config, do you see that the Open Networking part is a barrier of some sort?
Yeah, it's not a barrier. It's just that Open Networking Club, it just suggests that you have various projects here, and you have only ONOS config now. But I guess that you with the time you're going to add a lot of other components, and I guess they will mix with the other projects that you do with the Open Networking Club project. So probably at some point it will be good to have its own project. I don't know. I mean, it's of course just a suggestion question.
I guess
so kind of like how the ONOS project is off doing, it has its own GitHub org. Is that what you're looking for?
Yeah, something like that.
I guess ours was sort of following the structure of OpenConfig. I mean, that's OpenConfig has, you know, a few different, you might call them top-level projects, GNMI, Golang, Goyang, and YGOT. And I don't see any real, you know, problem with keeping these top-level projects under Open Networking Lab. In fact, it's also the hub at which you can access a lot of different open networking GitHub projects at the moment. All the ONOS code is in there, and I think Stratum is being organized in that way as well. Am I right?
Yeah, it was more of a question, not.
Okay.
Yeah, no, we kind of assumed that it was going to be kept under the open networking umbrella. Adeep, are you on, and are you able to talk? If so, I was going to ask you if you feel comfortable going through some of your API proposal, or if you would rather wait perhaps for the next meeting. I don't want to put you necessarily on the spot, but I want to give you an opportunity to be ready for one.
Hello, everyone. Actually, I'm exploring a unified API on top of GNMI, GNOI P4 runtime. So I started working on it just for a few days. So it's not completely ready, the specification, but the whole idea is that I think we can have a unified API on top of all of these API, because if you look at all of these APIs, they follow the same paradigms. So they use a streaming, they use read-write paradigm. So I think we can have a unified API as a node spawn on top of that. But for sure, it has some consequences because we are adding a layer on top of these APIs, and we introduce delay. So I still need to work on it. So probably I should implement a prototype of that to see if it's feasible or not. But I can share the specification with the group if the group is interested. So it's an early.
Adeep, just a question from my side. What is the ultimate end goal of this overarching API? Is this something that covers, for example, operations such as device reboot that includes like draining the traffic, providing an update of the device itself, then making sure the device is okay? Like a workflow, is that the end goal of the API, or maybe I'm missing something and this API is a lower level?
No, actually the API is that whatever we have now in GNMI, GNOI, and P4 runtime as RPC functions. So the goal is that we should have just four high-level function: fetch, store, streaming, and a command operation that we can use as a proxy to implement all of those functions. So actually the whole idea is that we should have a proxy that sits between the clients and the sourcebound interfaces to translate our functions, our API, to GNMI functions, GNOI functions, and P4 runtime functions. So instead of having, for example, GNMI as a northbound interface, and use GNMI functions to communicate with the configuration subsystem, so we can just use the unified API to communicate with the configuration subsystem. So that's the whole idea. The idea is that we need to minimize the number of functions that a network manager needs to use to configure, to control the network devices. That's the whole idea. But for sure, it has consequences. There are some trade-offs because we are adding a layer on top of all of these layers, and this layer introduces delay. So you can think of as a proxy that sits between the southbound interfaces and the clients. Is it clear or?
So yeah,
I have some thoughts of my own. I mean, there's clearly a benefit in the sense that you could have a unified API overarching different lower level APIs. The one trade-off you clearly expressed is delay and more latency. The other one that I see is that this would become somewhat of yet another standard, if you see what I mean, that somebody needs to agree on. And in some sense, OpenConfig and GNMI, GNOI, and P4 runtime are already agreed upon, and then we would have to make people agree on this. Do you see my point?
Yes, but the reason that I'm proposing as a proxy is because of that reason that you explained. In this model, everyone will be the winner. So because we don't change the P4 runtime southbound interface, we don't change GNMI southbound interface. So we expose a northbound interface on top of all of this stuff. So you still need to implement the P4 runtime server. So following the P4 runtime specification. So we don't want to change that. So we are exposing a northbound interface on top of that. So to make things easier, that's it. So, but everyone will be the winner, even if a new interface comes up. So we can add that as far as follows the paradigm that other APIs follow. So streaming, read-write. So, but I totally agree with you. So if we don't think as a proxy, suppose that we want to propose an API for everything, for configuration, for control, for management. So yes, you are right. So we are competing with other standards. What we are not competing with other standards, we are exposing a northbound interface on top of all of these APIs.
So yeah, we should probably learn more about this particular proposal. So if I can, so you've shared a document with me. So do you want to share that with the TST first to get a first round of feedback, or would you prefer to maybe present it at a TST forum next one so that we can give you adequate time for preparation? How would you want to do you have any preference?
I can share the document. It's okay. It's completely open because I have it in the GitHub repository. I will send a link to the group. So if it's that okay, I also can prepare a presentation for that. So, but again, it's completely in the earlier stages. So I should check the feasibility and see the trade-offs. So for sure, there are some trade-offs. So, and the delay is the most important one, in my opinion, because we are adding a layer on top of that. Suppose that later on, we would like to have an intent-based API on top of this API. So we are adding 2 layers on top of the southbound interface. So we need to consider that for sure.
Yeah, and so that sounds good. And I'm actually not, at least if I understand the spirit of this, I'm not terribly concerned about the additional layer, because the way I look at it is the existing, let's say, configuration APIs going to have GNMI on the north, GNMI on the south, and on top of it we can layer additional things. And I guess I view this sort of a unified API or potentially unified API as that additional layer on top, just another way of accessing the functionality potentially through a more unified comprehensive.
Yes, that's another potential solution. So we can think of as a kind of high-level API on top of everything, on top of GNMI. So if you assume GNMI is the northbound, P4 runtime also is northbound. So, but if you want to propose a northbound as a unified API, so we can use this model as well.
Yep. So sounds good. And also, when it comes to the control aspects, I definitely also want Carmelo to be able to take a look at and evaluate it, because he has, he has a lot of experience with P4 runtime and with designing the abstractions, the pipeline, independent abstractions for ONOS.
Okay.
Yep.
So I will share the document with the group.
Sounds great.
Thanks.
So would 2 weeks from now work okay?
Well,
or do you want to do it next week?
So actually, I think 2 weeks later, I will be traveling up to California for the internship.
Oh, that's right. That's right.
So probably we should postpone it when I arrive there, and I will present it from there. Is that okay?
That sounds good. That's perfect. Yeah. Because I think there's a lot of work that we still, can do without really any impact to this anyway, or any impact from it also. This is great. Are there any other questions or comments? If not, then I think
I was asked to join this. I was asked to join this meeting a while ago to talk about CI/CD and how that relates to using GitHub as a hosting platform.
Yeah.
Did people want to talk about that?
Yeah, that would be great. Actually, that would be awesome.
Yeah.
So,
do you have something to share, Zach, or?
I don't, but I can. I could probably take people on a walkthrough of what was done for the OMEC project, which is similar. So if I could share that.
Yeah, that would be great. Because I know that you left a number of comments on that council.
Yeah, I can get. So another project that's going on inside of ONF is OMEC, which is mobile focused. But one of the ways that we integrated them is they had some specific larger CI/CD jobs that they did, and how we did that integration was they wrote Jenkins files. They're actually hosting their Jenkins files on GitHub, and so they have this is a fairly involved testing job. They actually have physical servers. They have some build steps that they do that are, this is a repo and this is another repo and a few other things that they build that they go through, and they in the Jenkins file, they fork off jobs that do that, and then they eventually run a regression test. So the way that jobs were structured and the way that we had to do this in GitHub, so we also have a traditional, the way that we've been handling jobs through our Jenkins infrastructure is we use something called Jenkins Job Builder, which involves taking or creating YAML files that are then used by the Jenkins Job Builder program to reconfigure Jenkins. So, and the way that jobs get run is by a triggering process. So if you have in, like if you look at one of the OMEC jobs, they have this combined job that triggers. It goes through, downloads the Jenkins file. So this is OMEC C3PO combined. It goes in, runs the OMEC combined Jenkins file, and it runs this when there's a patch on this C3PO repo. Goes through, does all the tests, and all of the download and installation of code. Now, there's a pretty big delta between what you can do, what you can trigger on in GitHub versus what you can trigger on in Gerrit and some other code hosting platforms. And the biggest issue that we ran into was on Gerrit, you can do things like you can order specific jobs. So, for example, if I go back and I look at one of the other jobs that we have, like let me go back to us, because I know that has several jobs in the row. It lets you say let's say you're going to verify that that there's correct licensing and versioning on the repo. And you come down here and there's this job causes this job group to get run, and you can set a dependency between jobs. So you can say, don't run the license check, then run the version tag check, and it has to run in order. Well, that ordering is not possible in GitHub. The triggers are not that smart. The triggers are basically start this repo, and then you have to have a single job that returns true or false, whether you can get that, whether that patch set should be allowed to be merged. So what this means is that rather than having sort of a granular pick the jobs for your for commits, you need to have some sort of a meta combined job that probably needs to be written in Groovy to get those to run if you're going to have multiple jobs on a repo. Whether you decide to put that Jenkins file within the your specific code base. So for example, you could maybe in that in the ONOS config repo, you might have a Jenkins file that handles all of these things. When you see a new commit, because you have the Jenkins file stored with the code, you can evolve that Jenkins file as things change. That would be probably what I'd recommend if you want to use the Jenkins and GitHub interaction. Now that doesn't handle the triggering side of things. Triggering, you either have to go through and go over here and configure your Jenkins job to use that, or you can do it through Jenkins Job Builder, which is probably what I'd encourage you to continue to use. And the triggering on that, the triggers will automatically create your hook on GitHub to hook that code review. Now that handles the pull request. That doesn't handle ongoing tests after merge. So you need to have a separate job that triggers after merge if you're going to do post-merge testing that is beyond the scope of GitHub commit testing. This all is only really matters if you're going to be using Jenkins as your CI pipeline. You could decide to use something else. You could use Travis or whatever other maybe more GitHub friendly platform. It also, because of the way that the trigger works, it doesn't let you do some other useful things. So for example, we have the ability in Gerrit to only trigger so for example, we have some documentation jobs that will only trigger when they see there's a change in the documentation and matching a regex on the documentation or matching markdown files. So you might not want to have a full test run happen on just documentation changes. And that's not really possible with the GitHub triggering plugins. I just want you guys to go into this with your eyes open and make sure that you don't want to ask the system to do things that it's not quite capable of doing at this point. Of course, triggers could be written that are smarter, that understand or get more out of the API, that maybe pre-check the contents of a patch set before you run tests. So And it also was good to see from Sean that he has some unit tests that could be run in this sort of manner. Getting those hooked in, I can help with that, or I can at least point people in the right direction of getting those set up and ready to be run on new commits.
This is great. Yeah, it's definitely good to know what the limitations are and what to expect.
So Zach, just to clarify, when you say a new merge, that's a pull request or is that an actual commit?
Okay, so you need to have different triggers depending on whether it's a pull request. So there are a couple plugins that are available. One's the pull request builder plugin, and there's also one that will trigger the normal GitHub trigger plugin will work with merges. So it's two different hooks that need to be installed on a repo.
And are you using both for the one that you had set up?
We are currently only using the pull request one, not the merge one.
Okay. That's actually the more important one. Yeah. Okay, thanks.
Yeah. So this is all pretty well integrated. It's just kind of fiddly to do it the first time, and then things happen pretty quickly.
So Zach, have you seen the Go tools, and what's your thoughts on using the Go utility itself for, sort of running those tests, or what you think of like where Bazel fits in and all of those kind of things?
My take is that the so are you talking about the unit testing tools? I know there was what is it, Goland CI or what that was being proposed in the document.
Yeah, there was.
Yeah, I'm more familiar with Go MetaLinter, but it looks like it does about the same thing. My take is that all the tests that somebody would want to run that will pass or fail their code should be runnable by the user, by the developer. So a developer should be able to come in and say, make go test or run a make file that performs some more involved tests. I just don't like surprising. I don't like people being surprised by their tests failing. And having some common command, which is generally why I wrap things with make files, and so that everybody can just know that if I type make test in a repository, it will always run all the tests and validate things. That's sort of what I prefer. If you guys decide that everything's going to be Go based and you can just default to running the Go test command, that also could be useful as a convention. One other thing is Go doesn't by default output coverage or test results in a machine consumable fashion. There's some tools that we came across that let you convert to JUnit and Cobertura formats. I can show you where in the system that those are installed, if on the cord side of QA.
Okay.
Does that answer the question?
Yeah. Thanks, Zach. Yeah, no, there's really I'm a long way from like being knowledgeable on anything to do with Jenkins, really, and I just wanted to kind of know how's that Gulf kind of bridged. But like you say, if the developer can run their own Go tests locally, I think can on the integration side, it should be possible to automate that.
Yeah, no, absolutely. With respect to as many of the tests, not actually just necessarily limited to unit tests either. As many of the tests should be accessible to developers to run, barring special infrastructure being in place, needing to be in place. But therefore, I think anything for Go, if it's Go test, that's great. Analogous to make, we will most likely end up using Bazel to provide any bridging or any actions, either bridging between languages or potentially actions that kind of are higher level that kind of escape the scope of Go. we will most likely rely on Bazel to do the same thing. So like Bazel test will most likely be used to run all of the test related targets.
Yeah, makes sense.
Yeah, that does. As long as there's a common convention, that's what matters more than specific tools.
Exactly. Yeah. Yeah. The accessibility of developers to execute tests on their own. To me, that's key. Thanks, Zach. This is great.
Thanks, Zach.
Make some trade-offs and decisions in the future.
Yeah, sure. Feel free to reach out to me as you need.
Andrea, you were going to say something?
No, I was just again, yeah, thanking Zach for the contribution, and I think as soon as we get to this, and we probably out to get to get at it sooner rather than later, I think we'll reach out to him, understanding at least a few other technical details, and maybe coming up with a proposal for our own repo and then running it through Zach and everybody.
Yeah. Well, we're a little bit past the time now, so probably a good point time to wrap up the meeting. Thanks everybody for productive discussion. We'll try to schedule these this particular topic periodically for the TST meeting, so that we can keep abreast of the progress. On just a brief parting note on ONOS 2.0, we're nearing the Raven release. I think the plan is to release sometime next week, which will be on time for the original April 29th release date. We will also be scheduling a demo as well as a planning meeting for the S release sometime soon. So I'll be sending out dates for this. Most likely the review and planning meeting will be at the end of next week.
Tom, just a final comment. I think it's worth scheduling one about ONOS NG the week after the second week of May, meaning the 15th to the 14th to the 20 something.
Yes.
In order for us to update everybody on some of the thoughts we will be discussing in our work week.
Yep, that makes sense. I agree. All right. Well, thank you, everybody. I think we can call it a day, and we'll see you next time. Bye-bye.
Take care. Bye-bye.
Bye.
Thanks. Bye-bye.
Bye.